lattice energy, right? So let's start with our lesson today, that is about a past paper question. So question starts with part A, that is lattice energies are always negative, showing that they represent exothermic changes. Explain what is meant by lattice energy. So you will simply be defining this term, that is lattice energy. That is like it's the enthalpy change when one mole of ionic compound is formed from its gaseous signs under standard conditions, right? So it worth 2 marks. That was easy to attempt this part. And then second part is explain why lattice energy is an exothermic process. You already know why lattice energy value is exothermic, as I had explained this to you in my previous videos. So if you want to get an idea again, then you can watch my previous video. The link of those videos will be shared in description box. So again, I will be discussing this second part, that is explain why lattice energy is an exothermic process. So due to the formation of an ionic compound, so overall when ionic compound is formed, so overall what you say, energy is released, and that's why you say that this is an exothermic process, right? So this is the data which you will be using in part B, right? So when you will be calculating lattice energy of potassium oxide, then you need some enthalpy values which you can pick from this table, that is table 5.1. So question is use relevant data from table 5.1 like this one to calculate the lattice energy, delta H standard lattice of potassium oxide, and we are supposed to show our working as well, right? So first of all, you'll be writing equation, that is delta H standard lattice is equal to delta H standard formation minus delta H standard ionization. So the values which are given in this table, you can pick those values and can slot in this equation. So you can see that this is like lattice energy of potassium oxide you are supposed to calculate. So what I have done here, I have just calculated delta H standard ionization firstly, and then I have slotted in all the values, and then at the end I have calculated delta H standard lattice. So delta H standard ionization is equal to you can see 89 value is given, that is like standard enthalpy change of atomization of potassium, and you can see that there are 2 moles of potassium, so its enthalpy change of atomization will be multiplied by 2, plus you will be writing 418, that is the value of first ionization energy of potassium. And again, as you have 2 moles of gaseous potassium atoms, so again if both of those gaseous atoms will get ionized, then it will be like first ionization energy value will be multiplied by 2, right? Then I have shown 496 divided by 2. So let's see whose value is this one, that is like bond energy for oxygen, that is diatomic molecule, right? So you will be dividing this by 2, reason because in K2O only 1 mole of gaseous atom was required in the beginning. So you will be taking bond energy value and will be dividing it by 2, that will be like enthalpy change of atomization of oxygen basically, right? So next is negative 141, that must be electron affinity of oxygen, right? First electron affinity, plus 798, that is second electron affinity, this one of oxygen, right? So first of all, you should calculate delta H standard I, that is equal to sum of all of these enthalpies, and then after getting one value, that is of delta H standard I, after calculating this one, you will be getting like 1919, that is delta H standard ionization. So after getting this value, you can pick delta H standard formation value from the table again, right? This one minus 361. So by slotting in this value, which is delta H standard formation minus of this equation, you will be writing the value of delta H standard ionization. So just solve this expression, and at the end you will be getting an answer, that is minus 2280. So that is the answer of delta H standard lattice of K2O, right? So in the second part, they are saying state how delta H standard lattice of sodium oxide differs from potassium oxide, right? So you are supposed to compare latest enthalpies of sodium oxide and potassium oxide, and they are saying indicate this by placing one tick in this appropriate box in table 5.2, right? So I have put a tick in third column, and what is written as the heading over as a heading in this column, that is delta standard sodium oxide is more negative than delta standard latest of potassium oxide. So how did you pick this one? Like, why you did not pick first two columns? The reason is written in this box, that is sodium ions, basically its ionic radius is smaller than potassium ion. So if the ionic radius of sodium is smaller than potassium ion, it means charge density of sodium ion will be greater, right? So sodium ionic radius is smaller than potassium ion, so greater attraction and more negative value, right? So this is the reason, because of which I just put a tick in third column, right? So on what basis did you choose this third column? You will be saying delta standard latest depends on charge density, and if the size of one ion is greater as compared to the other one, and if they both are having same charge, so the one which will be having smaller ionic radius, that will be having greater charge density. So because of that greater charge density, you will be saying attractions between positively charged ion and negatively charged ion will be greater. So overall more energy will be released and more negative value, right? So that was the answer. So you are done with question number one, that was a past paper question, and now we can discuss another question, which is question number two, and we'll be discussing only 3 marks question, then we'll be ending this video. So this question is, use the following data to calculate a value for the latest energy of sodium chloride, right? So again you will be writing equation firstly, that is delta H standard latest is equal to delta H standard formation minus delta H standard ionization, right? So again calculate delta H standard ionization value, that is equal to sum of these values, these enthalpies. So after solving this step, you will be getting a value for delta H standard ionization, that will be equal to 374. Simply slot in this value in delta H standard ionization slot, and then instead of writing delta H standard formation, you will be writing its value over here, that is minus 411. Minus is of this equation, and then in bracket you will be writing this value. So just solve this expression, and at the end you will be getting a value, that is minus 785. That is the answer, right? So latest energy of sodium chloride will be equal to minus 785. So whenever you will be doing these calculations, so it will be easy to calculate delta standard ionization firstly, to avoid any confusion, and then simply slot in the values in the main equation, and then you will be getting accurate answer. So this was all about for today's video, students, and Allah Hafiz everyone.